So let's see.
So it'd be 0.009 meters?
Just 0.09.
And that should get us our answer.
Mm-hmm. That'll be in meters per second squared.
So the main thing to remember is the units. And that's what tripped me up, was the units.
Mm-hmm.
So we need to convert any meters to centimeters. And we need to convert any RPMs into revolutions per minute.
Mm-hmm. Basically the safest way to do any problem. So newtons are in meters, kilograms, and seconds. And those are actually the base units for the SI system. Kilograms, meters, and seconds. So if you have anything that isn't kilogram, meters, or seconds, you can convert it into kilograms, meters, and seconds. And then you'll know for sure that your calculations all work out. And then angles, at least in rotational motion like this, it's best to put them in radians rather than revolutions. So if you see RPM, you can do it sometimes in RPM, but the safest thing is just to put it in radians per second. You'll still get the right answer.
Now, so really it's just pi. Okay, forget about the radians, it's just pi. Okay.
Right, so this is 3 pi radians per second minus 2 pi radians per second. Then you divide by seconds again.
In my calculator, I just type pi.
Yeah.
Okay, cool. Thank you.
Just like any other unit. Oh, shoot. There's another part to this problem.
Really? Is there part B?
Yeah. It says,
Number 4.
what length of chain passes over the top of the sprocket during this interval?
Oh.
So you've got a chain going across this, right? And it goes down and around. And it goes back out to the rear derailleur.
Uh-huh.
Okay? So just this point right here. How much chain goes over the top of that?
So how would I find that, is my question.
Okay. So let's say, so it's spinning, right? So how do you compare how fast it's spinning to how much chain is going around the outside of that?
The distance?
Yep. So the distance around the outside, right?
Mm-hmm.
So every time this sprocket goes around one time, how much chain has gone over the top of it?
From the looks of it, 10 centimeters worth. Well, no. It would be half the circumference.
Yeah, so if it goes around just one half, then it'll get half the circumference, right? So which means even though it comes off, like this chain keeps going around, right? So even though it isn't in contact here, how much chain continues to go around it as you go around the other half?
So what can we use to solve it?
Just like what you're saying, so for every revolution, the chain goes 1 times the circumference.
Oh.
Right? So we'll use that. If we can find out how many revolutions it goes, we can find out how much chain went over it, right?
We can find what?
If we find out how many times the sprocket has gone around in that 10 seconds, then we can find out how long, like how much chain has gone around it, right?
Okay.
So what we want to do is find the angular position. So we can use this equation right here. Actually, yeah, we'll use this one. 1/2 So what's our yes, it's this equation.
Okay.
So the so the final angle is what you're looking for, how many times it's gone around, right? The initial angle, what will we call it? We can start from wherever we want, so we might as well start from 0. What was our initial omega?
Um, 60.
Okay, so what do we want to use 60 here? Or
No, we want to use our final. I don't know.
well, we want to use the initial one, but 60 is RPM, so we want to use 2 pi radians per second.
Mm-hmm.
Then we can just multiply it times our 10 seconds, right?
Mm-hmm.
Plus 1/2. What's alpha?
What we found up there. The final minus initial divided by t.
Yeah, so it's just this part. 3 pi minus 2 pi all over 10 times 10 squared.
That's alpha?
This, yeah, right here. Because you remember we have this.
But we're not timesing it by 10.
Oh, this
That's
is just
pi.
alpha
That's
times
pi.
t
Okay.
squared, yeah.
Okay. So we have 2 pi times 10 plus 1/2 times pi divided by 10 times 10 squared.
Yep. That'll give you a final angle.
Mm-hmm.
So that'll tell you how far it's gone, just in an angle form. And what will that angle be in terms of? What would the units be on that angle?
Well, it's an angle, so shouldn't there be no units?
Well, yeah, kind of, but it's the radians, right?
Mm-hmm.
So it isn't in revolutions and it isn't in degrees, it'll be in radians. So whatever this answer is, you'll have in terms of radians. So if you want to find the actual distance traveled, you could say, we'll call it S. It's equal to alpha times your radius. I mean, not alpha, theta times your radius.
Which is how we get the length.
Yep. So we'll take this theta that we just found, we'll put it in here. And what radius will we use?
10.
Yep. And you can have this in 10 or in 0.1.
Okay.
You just remember which one you use because that'll tell you if your answer's in centimeters or meters.
Wow, that's really cool.
Yep. So if you have something spinning like that, the distance that's traveled by the chain going around it will be just the angular distance times the radius.
Okay, cool. I appreciate that.